Imagine the unthinkable planets colliding. It's not science fiction. Early in the solar system's history, collisions were common. Planets formed, smashed together, and reformed. Today, these events are rare, but not impossible. What if two giants collided? Neptune and Uranus, the ice giants of our solar system. A cosmic crash of unimaginable proportions. Let's explore this hypothetical cataclysm. We'll delve into the chaos, the destruction, and the potential for new creation. Join me on a journey to the edge of cosmic mayhem. Picture this: Neptune, the blue giant, on a collision course with Uranus. Their gravitational pull intensifies as they draw closer. The planets accelerate, hurtling toward each other at incredible speeds. The first contact is cataclysmic. Their gaseous atmospheres collide, compressing and superheating. Shockwaves ripple through both planets. The energy unleashed is equivalent to countless nuclear bombs detonating simultaneously. As the planets smash together, their internal structures are obliterated. Cores of rock and ice shatter and melt. Mantles of water, methane and ammonia vaporize. The once majestic planets are reduced to a chaotic inferno. The energy released in this cosmic collision is staggering. Imagine the force of millions of nuclear weapons detonating at once. That's the scale of destruction we're talking about. This energy manifests itself in several ways. Intense heat vaporizes massive amounts of planetary material. Shockwaves propagate through the solar system, disrupting the orbits of nearby celestial bodies. And a blinding flash of light, visible across the galaxy, marks the moment of impact. The collision creates a massive debris field, a chaotic mix of pulverized rock, ice, and superheated gas. This debris cloud expands outwards, scattering fragments across the solar system. Neptune and Uranus, once majestic giants, are no more. The collision has obliterated their structures, leaving only a swirling cloud of debris. Their atmospheres, once distinct and colorful, are now a superheated mixture of gases. The cores of these planets, once solid spheres of rock and ice, have shattered and melted. The intense heat and pressure of the impact have transformed them into molten masses. These molten remnants will eventually cool and solidify, forming new, smaller objects within the debris field. The collision marks the end of two planets, but it also marks the beginning of something new. The debris field, born from destruction, holds the potential for new celestial bodies to form. Out of chaos, a new order may emerge. The collision leaves behind a massive debris field, a chaotic mix of planetary fragments. This debris cloud spreads outwards, forming a ring of cosmic shrapnel around the Sun. This new debris field resembles our solar system's asteroid belt, located between Mars and Jupiter. But this new belt is far more extensive, containing the remnants of two planets. This vast collection of debris poses a potential hazard to other celestial bodies. The debris field is a dynamic environment, with fragments constantly colliding and interacting. Over millions of years, these interactions could lead to the formation of new, smaller celestial bodies. From the wreckage of planets, new worlds could emerge. Imagine this. Within the chaotic debris field, a new planet begins to form. Gravitational forces pull together scattered fragments, gradually coalescing into a larger body. This process, known as accretion, can take millions of years. As the new planet grows, its gravity attracts more debris, accelerating its formation. Eventually, a new world emerges from the wreckage of the old. This new planet would be unlike either Neptune or Uranus. Its composition would reflect the mixture of materials from both planets. Its size and orbit would depend on the specific dynamics of the collision and the subsequent debris field. The collision between Neptune and Uranus doesn't just affect those two planets. The entire solar system feels the impact. The massive energy release disrupts the delicate gravitational balance of our planetary system. Planets experience shifts in their orbits, some minor, others more significant. The asteroid belt between Mars and Jupiter is stirred up, potentially sending asteroids on collision courses with other planets, including Earth. The Kuiper Belt, a region of icy bodies beyond Neptune, is also affected, with objects scattering in all directions. These disruptions could have long-lasting consequences. planetary orbits might take millions of years to stabilize. The increased risk of asteroid impacts could pose a threat to life on Earth. The solar system, once a relatively predictable place, is now a realm of uncertainty. While Earth is far from the site of the collision, it doesn't escape unscathed. The ripples of this cosmic cataclysm reach our planet in subtle but potentially significant ways. The most immediate effect is the increased risk of asteroid impacts. The disrupted asteroid belt and scattered Kuiper belt objects could send projectiles hurtling towards Earth. While most of these would be small and burn up in the atmosphere, a large impact could have devastating consequences. Over longer timescales, the gravitational disruptions caused by the collision could subtly alter Earth's orbit. While these changes are unlikely to be catastrophic, they could affect our planet's climate and long-term stability. As catastrophic as this hypothetical event is, it offers a unique opportunity for scientific discovery. By studying the aftermath of the collision, we can gain invaluable insights into planetary formation, the dynamics of the solar system, and the fundamental forces that govern the universe. Analyzing the composition of the debris field can reveal details about the internal structures of Neptune and Uranus. Observing the orbital disruptions of other planets can refine our understanding of gravitational interactions, and tracking the evolution of the debris field over time can provide clues about how planets form from smaller bodies. This event, while destructive, is a cosmic laboratory. It allows us to study processes that are normally hidden from view, offering a glimpse into the inner workings of our solar system. The collision of Neptune and Uranus is a thought experiment, a cosmic what-if scenario. But it highlights the dynamic nature of our universe. It reminds us that space, while vast and seemingly empty, is a place of constant change and occasional chaos. This hypothetical event also underscores the interconnectedness of our solar system. Events in one part of the system can have ripple effects that reach across vast distances, affecting even seemingly distant worlds like Earth. Finally, this cosmic cataclysm reminds us of the power of scientific inquiry. By studying these hypothetical scenarios, we can deepen our understanding of the universe, its origins, and its infinite possibilities.